All right, so the next section we're gonna work on is our multiplication of fractions, okay? So multiplication of fractions. Now, when looking at multiplication of fractions, our process is pretty easy. You always go numerator always goes straight across. Numerator times numerator equals numerator, denominator times denominator equals denominator. We don't have to worry about lowest common factors now. We don't have to worry about like denominators because we do the multiplication straight across. So we're gonna look at two parts of this. We're gonna do a fraction times a fraction and a fraction times a whole, okay? So f times f, f times w, okay? Now, these two examples are in your slides. They're questions 18 or slides 18 and 19. So looking at these right here, let's look at question 18 first, a fraction times a fraction. So it says a survivalist has 1/2 of a map left, 1/2. If they give 1/3 of a piece, of that piece to a friend, what fraction of the original map does it have left? And we always talked about that when you have a fraction times a fraction, it is a portion of your total. So your product, okay, product always means multiplication, will be lower or less than your original portion, your original total that you have. We talk about this as a total. So you have half a map and you give 1/3 of that piece, 1/3 of your half to a friend. What fraction of the map of the original map does that friend have? So what portion of the whole map? So we look at 1 times 1 equals 1, 2 times 3 equals 6. All right, that's our answer. It's easy to look at it this way right here, okay? 1/2, okay? And we'll say this is yellow. All right, half of my map is all that I have. Then you go to thirds, okay? So columns times rows. We'll talk about that again here in a second. 1/3. All right, we see that this is now divided into thirds and rows, and then columns is in half. So I have done 1/3, 1/2, and I have 6 total spots in this whole map now, and only 1/6 is actually represented by the portion what the fraction of the original map does the friend have, because you're giving 1/3 of the half that you have, okay? Remember, this is our total, and we're putting it into taking a fraction of that total, okay? Now let's look at our fraction times a whole number. All right, this is going to be slide 19 in your slide deck. This is batch cooking. So a recipe for trail bars needs 1 3/4 cups of oats. Sounds delicious. If you want to make 3 batches, how many cups of oats do you need, okay? Times 3 here, okay? So the first thing we need to do is make these look like improper fractions. With the whole number, it's easy to do because 1 over 1 equals 1. So 3 is 3 over 1. All right, then 1, 3 over 4. All right, so we look here and need to get this to improper fraction. We go 4 times 1, because that's a whole, 4 over 4. So it's 4 times 1 is 4, plus 3 is 7. So we say that our problem is 7 over 4 times 3 over 1 equals 7 times 3, 21. 4 times 1 is 4. Now, 21 is not divisible by 4. So we have to figure out how many wholes we can pull out of that without going over 21. How many 4s can we do without going over 21? Well, we say 4, 8, 12, 16, 20. So that's 5. 5 is our whole number with a remainder of 1 over 4. So if you want to make 3 batches, how many cups of oats do you need? 5 1/4. All right? Now, if you were to represent this as a model, you would sit there and say, I have 1 3/4, okay? 1 3/4, okay? And I need to make 3 batches, okay? So I'd say so 3 batches, and the recipe calls for this much, okay? So I say 1, so 1, 1, 1, 1, 1, 1, 1. There's 1 batch, okay? All right, now there's 1 batch, okay? Now I need all right, so here's now we have our second batch, okay? And now we go here and we say, okay, we need 1. These are all divided into fourths. So we have 1 3/4. 1 3/4. 1 3/4. All right, I have now officially made my 3 batches, and the total amount that I need of cups of oats is 1 cup, 2 cups, 3 cups, 4 cups, 5 cups, and 1/4, because each whole figure here is 1 full cup divided into fourths. All right, now let's take a look at some of the models that we'll be looking at. So we talked a little bit about this fraction times fraction, especially in the case of saying that we are doing fraction times fraction, fraction times whole. We talked about this cross section. Look, some people call it purple product. It's perfectly fine to call it that, but it makes no sense to me to do red and blue and then call it purple when it's other colors sometimes. So we're gonna say cross section. So if we look here, we are always doing columns times rows equal our cross section. All right, so what is our division of this whole figure into columns? We say this 1 column, 2 columns, and 3 columns. It's in thirds, and only 1 column is fully shaded top to bottom. That fraction represented is 1/3. Now, looking here, now we talk about our rows. Rows go left to right, okay? So we talked about like columns hold up roofs, rows are like corn, left to right, okay? So we sit here and say 1, 2, 3, 4, 5, okay? 5 rows and 2 are fully shaded left to right, okay? I'll even circle this 1 here and then say 1, 2, so that way it's pretty obvious. Now, because it's multiplication, all we do is say 1 times 2 is 2, 3 times 5 is 10, 2/10 or 1/5 if you want to reduce it. But 2/10, so there are now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, sorry, 3 times 5 is 15. There are 3 columns, 5 rows, is 15 total boxes, and 2 are counted in the cross section. 1 and 2, okay? That's it. Now for fraction times a whole, you'll see figures that are individual. They are the whole. There are how many figures here total? 1, 2, 3, okay? That is 3 whole figures, all right, times the fraction represented in each of the figures. That should be the same. So we say 2/4 for each of them, or 1/2, that's okay. We'll get to that in a second. So 2/4 here, okay? 2/4 here and 2/4 here. 3, okay, or 3/1, okay, for our whole number as an improper fraction. 3 times 2 is 6. 1 times 4 is 4. 6/4 is a improper fraction. You can reduce it to 3/2 or 1 and 1/2 because we're 3/2. Okay, so our answer would be 1 and 1/2. All right, could you just do it by 2/4 and reduce first rather than doing it? Let's take a look. So this is definitely our answer. So 3/1 times 1/2 equals 3/2, which equal to 1 and 1/2. So yes, you can reduce that there, but I would say just do your problem with whatever's there, just to make sure you don't get confused. All right, that's all for that. Let's move on to division.